So now that several places in the world are switching to DST, we are seeing meeting times changing for some time zones on a week-to-week basis. I have here in my calendar that the meeting seems to be based on GMT time, which means that at least from what I can see from my calendar that I'm sharing now, that maybe I can share it now. The meeting time for today, this is in European time, which is 6 a.m., which will be then it's 10 p.m. US time, but the next instance that I can see here, it's falling at 7 a.m. European time, which I believe, I'm afraid it might still be 10 p.m. US time, right? Because there will be still 9 hours after that. And for China, it will switch at 1 p.m. It will be then it should be 1 p.m. So maybe if you can also review how the calendar is showing up in your time zone, that we can make a call on whether we want to change or not the times for the summer season, so that it's a fairly comfortable time for everyone. Let me see if it is 30. Is it just a one-off?
It shows up as 10 p.m. for me on the Google Calendar, but 9 p.m. on my VMware calendar for some reason.
Those are two different invitations, I believe.
Okay.
I believe that those are two different invitations. So let me see the invitation on the VMware calendar. I don't even know if I own it or somebody else owns it. So on the VMware calendar, the invitation is based on UTC plus one, which is not UTC. It's UTC plus one is pretty much Berlin time, and that's why it switches. On the Google Calendar instead, no, I don't want another meeting. On the Google Calendar, the invitation is in coordinated universal time, which means it's always 5 a.m. regardless of the time zone. And therefore, when we switch to daylight saving time for Central Europe, it becomes 7 a.m. And from the US, it becomes 10 p.m. Whereas for China, it stays always at 1 p.m. I believe, and then you can give me your feedback here, that maybe we should try and restore the 9 p.m. 6 a.m. Cadence, and this will mean that the meeting for China will go to 12 p.m. from 1 p.m. I think that might be the best approach, but anyway, we don't have to finalize it now. We have 2 weeks. I just want to hear if you have any feedback on this.
Moving it sounds good to me.
Okay.
I was the one that has to join early, so.
No, that's okay. Now I got used to the 6 a.m. meeting. And to be honest with you, 7 a.m. will probably conflict with the time for getting kids ready to school. So, yeah. All right. So that's all. I'll make the proposal on the Slack channel, so that if you have any feedback on that, you can provide more feedback on the Slack channel, and we'll finalize the meeting time change by the end of the week. Said this, we can go back to our agenda. The only topic that we have today on the agenda is a presentation of the design for the reject action in Antrea policy that will be given by Grayson. So I don't think there is any other topic in the agenda for today, is it?
Hi, Salvato. I think we are going to talk about the Windows kill proxy removal today.
Okay, yes, that's right, because that's a good point, because Vicky told me that we might be ready, but she didn't confirm me whether we were actually ready or not. So that's great that we also have the Windows Cube proxy removal. So I think, Jason, how much time do you think you need for the Windows Cube proxy removal?
I think maybe less than half an hour.
Oh, great. And Grayson, would like 20 minutes be good enough for you as well?
Yeah.
Okay, so maybe we can start with the Cube proxy removal for Windows, and then we can move to design for the reject policy. Is there anything else that you would like to bring up for today's meeting? Any other demo, topic, design, discussion, complaint, rant? Okay, yeah, go ahead.
Sorry, I thought Hongliang have some leftover things to talk about the Cube proxy removal for Linux. Hongliang, are you going to talk about it?
Okay, so is this like a follow-up from the previous discussion that we had on 2 weeks ago?
Yes, I think so.
Okay, so it might make sense to start with that, so that we conclude that discussion on the Linux Cube proxy removal. So maybe Hongliang, you can get started, and then Jiacheng will follow with the Windows Cube proxy removal, and then we will conclude with the reject policy for Antrea. Okay, so since we have quite a few topics to discuss about, I guess I guess you want to stop hearing me, and maybe we can hand it over to Hongliang.
Okay, thanks. Oh, wait a minute. Okay, this is a presentation about the design of replacing Kubi proxy, and there are some open items about the last meeting. First, is the masquerade action necessary? The second, support for out-of-cluster endpoint. Third, can entry controller rely on entry proxies service? Let's review the overall design. What are our design? First, we add an IP set to store the IP and port of services. In Mongo table, the traffic matching IP set will be marked with 0xF2. Third, add an IP rule, and this rule is used to route traffic marked with 0xF2 to a specific routing table. And the traffic is routed to OVS where entry GW0 and masqueraded on table net chain post routing. And the first question is the masquerade action necessary? For example, we run this command on the host node. As the source is dependent on the main route table, and the main route table is used to mask the target IP. If there is not an item matching this target IP, the packet will be dropped. Here, only the default route matches the cluster IP, which is the target IP. Next, we can say that the source of the packet is the IP address from the default route item. The destination is the cluster IP. Next, and we can see that we can't we can't decide the source IP address of the packets, as we can't decide which route item can matching the cluster IP. Here we can see that the source here and the destination. Then go on. The source is masquerade with entry GW0, and the destination is also the cluster IP. Okay, next, go on. Support for out of cluster endpoint. Continue with the scene on the previous page. We cannot let the packet. We can't let the packet with the source. Oh, sorry. We can see that the packet with source, with this source and this destination, it will be processed on table 41. And then it will be processed on 42. Its destination will be changed to its real endpoint. On table 70, well, normally this should be package should be matched with pod CIDR, and if the endpoint is not in pod CIDR, it will be matched with these items. The most important, before leaving OAS, this source should be modified to a virtual IP address. Why we do this? Because we can't let the packet that source is this 10.10.0.1 leave the OAS, and it will not come back again. So before leaving OAS, we modify its source IP to this virtual IP, but and it's not net. Next, on the host node, if the endpoint is not on localhost, we need to masquerade it again with this physical IP address, because this virtual IP can't be routed back on the physical network. And its source is modified to this one. The host, this is the IP address of node 1. Okay, and the traffic will come back from node 2. Now, and SNAT and recover the source, recover the destination to this virtual IP address. Routing decision, we need to route the traffic into OAS again, and we need to add this unlinked route item to main route table. And here, we also need to recover the destination IP address to the entry GW0 on OAS. And it will be NDNet on OAS to the source will be modified to the cluster IP address. Next, the traffic come back to node 1 with SNAT, with SNAT. Now, the destination will be changed as to the IP address of original. and then this, and then the process is done. And the third question, can entry controller rely on entry proxy service? The entry controller, the entry client will wait for the entry service until the entry proxy is ready. Okay, that's all the problem. Any questions?
I just thought of one problem here. I think your design probably doesn't work for light policy only mode, right? Because I think you I think it's one flow. You assume the IP is the Antrea GW0 IP.
Oh, can you tell me which page we should jump to?
But in the policy only mode, we don't have any IP on GW0. Really.
Policy. Oh.
Just scroll down. I think it's in page 7. Okay. In page 7, you mentioned some flow. Yeah, this one.
This one.
What does that set field 10.10.0.1 mean?
Oh. We need to the packet now with the destination with this IP address should be modified to this one as we modified here. As we modified here. We can't let the packets out live in OVS with this IP address because its reply traffic will not be routed into OVS as this IP address is the IP address of the network adapter on node 1.
Okay, that is that is IP mask created by your IP table sub mask create. Sure, right? But I mean, in that policy only mode, I think we don't have any IP on GW0. So in that case,
sorry, I didn't.
Okay, probably let's talk offline now. Maybe you don't know the net policy only mode. So
Yes,
you see we have traffic. We have 3 traffic mode, right? In-kind mode. 4 mode. In-kind mode, hybrid mode, no in-kind mode, and there's another mode called net policy only mode, in which we don't encap traffic and we don't really route traffic, but we need some other thing I plugin, typically some cloud native plugin to for the traffic and the route traffic. So in that case, we don't have any IP on GW0.
Oh, sorry.
So probably let's talk offline. I guess you didn't pay attention to that one.
I didn't take it into consideration before. Maybe. Sorry.
Yeah, no problem.
Is there any additional comment on the Linux Q proxy removal? Hongliang, is there anything else that you'd like to add on your presentation?
No, not.
Okay, perfect. So thanks for presenting this, and thanks for the feedback from Jianjun. And we can move to the next topic, which is same thing, but for Windows, and which will be presented by Zhuecheng.
Okay. Hello, Hongliang. Could you turn off the sharing screen sharing.
Great. Okay.
Okay. Can you see the screen?
Yes.
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 I think I should send the link to you guys. Yes. So today I'm going to talk about the kubeproxy removal on Antrea Windows. First, I need to thank Ray for his knowledge transferring and his effort on the design, and he offers this chance to do the representation today, and all this credit goes to him. Okay, then let's get to the topic. Currently on Antrea Windows, the class IP service from pod is supported already. There's a service LB do the endpoint selection in OVS, and there are some other services like node-pod service and class IP service from host. These are still depend on the kubeproxy, and we want to remove kubeproxy, so we need to support these services by our design. The reason to remove it is by using Antrea proxy, we can have the full control of the pipeline, and we can make it more efficient. Basically, there are 3 sub-tasks here. First, we need to support class IP service access from host. Second, we need to support node-pod service access. And third, which is a work in progress issue, we need to rearrange the bootstrap order. But it maybe is the same as the Linux case, but we will need to investigate more. And on Windows, before Antrea agent is installed as a process, the kubeproxy need to be installed. So to remove it, we need to stop the kubeproxy process, and we need to remove those servicing interface introduced by the kubeproxy. Yes, so let's get to the first task here. You can click on the link here. Yes, so the first subtask is support class IP service access from the host. Currently, you can see that we have kubeproxy here. So if a local process on Windows host sends its packet, then kubeproxy will receive it, and kubeproxy will take care of the packet and send it to the selected endpoints. Yes, kubeproxy will do the endpoint selection as well. But now we want to remove the kubeproxy, and since we already have the service load balance do the endpoint selection, we just need to do something here. We need to make sure that the packet from local process can go to the Antrea GW0. So here's the solution. There are 3 things we need to do. We need to add a route for the service IP, which is the destination, to redirect to the traffic into the OVS bridge through Antrea GW0. We need a route here. Also, we need an AIP responder in OVS for these service IPs. And third, we need some additional flows to make sure the path is expected. You can see that there's 2 routes here. Of course, we want to limit the number of AIP responder in OVS. Because if we have, if for each service IP we add a new AIP responder, then there won't be too much, and we don't want it. So we want to use a virtual IP to represent all these service IP. So that we need only 1 AIP responder here. And so with these 2 routes, the local process can go to the correct endpoints. And when the packet was sent back, the logic is similar here. And here are some example command on Windows to do the job, to add the route and to add the AIP responder. There's some possible improvement here that since about the route table on the host. We have this service IP as destination, this route, and if you have another service IP, we need to have another route here. As you may remember, in Linux, we have a IP set to collect all these service IPs, and it is a very, very fast speed in time in terms of time complexity. So we are going to investigate if there's something like IP set on Windows, so that we can let the number of routes in the route table to be just one route here. Yes. So this is basically the class IP design. It is very simple. We just need to add a route and a relative AIP responder, and the service LB will do the rest of the jobs. So is there any question about this part?
Zhe, I'm just thinking that we assume that it can be multiple physical interface on the node. If not, then anyway, the traffic, even you don't add routes, the traffic anyway go from BR-int to OS bridge, right? If we assume there's only one interface and only one IP on the node.
Only one IP.
For example, if it's just let's assume it's a virtual machine.
Yes.
And they only have a single VNIC. And since we
Yes.
move the VNIC to OS bridge, then all the traffic, even you don't add any routes, any static routes, by default the traffic will go out from BR-int, right?
Yeah. Are you sending the packet from the host or on the OVS?
Sure. I think you talk about some local process to access class IP service, right?
Yes. So if it is a process on the host, it must go through Antrea GW0 to get into the BR-int to the OVS. So
not really. I mean, if let's assume you don't do anything on the host, but you only have a single VNIC, then the default route, there must be a default route, I think, point to BR-int, right?
Yes. If you access, for example, the external IPs from the host, the traffic will go through the BR-int by default.
And here we add routes because you guys want to assume we have multiple interface on the node. So the default route is not BR-int. Is that assumption? So we need to add the static routes to redirect traffic.
That's one of the considerations. Another is that because on Linux, we use the Antrea GW0 for the class service traffic. So we want to keep the same behavior here.
I see. I think at least for that one, you have a way to redirect traffic from BR-int directly to GW0 using open flows.
You will send the reply packet back.
Maybe what I'm saying wrong. So I guess you mean you want to keep the open flow to be the same between Linux and Windows.
Yeah, and if the traffic goes through the Antrea GW0, the source IP will be the gateway. Will be the IP of the Antrea GW0. So it's easy to be sent back for the reply packets.
Okay.
But Janjun, don't we also have flows in the pipeline that treat packet going through BR-int and packets going through the gateway differently? I thought we had such flows on Windows where we classify the packets differently, whether they come from the host gateway port or through the bridge port.
Right. But for flows from BR-int, I think mostly we just redirect to uplink directly.
Yeah, and that's not really what we want to do here, right?
Right. Okay, probably I need to think about it a little more. Already I thought on Windows it can be simpler, but I mean, if we have to handle routes, then probably it's not really simple.
Yeah, I got your idea. So just we can consider if we can leverage the BRInt to avoid introduce the additional routes.
Right,
Okay.
that's what I'm thinking of. But if we want to support the case, you have multiple interface, maybe it doesn't work.
Yeah. So I mean, the current plan is very easy, and because the design is also run on the Linux, so we are confident for this design. But if we move the traffic to BRInt, we may need to consider more.
Okay.
But it's a good idea.
Okay.
Thank you, Andrea, for your question.
Yeah, probably let's think about more. Yeah, thanks.
Okay. Is there any other questions? Okay. If there's none, let's move on to the next part.
Antonin, do you think that your question do you want it to answer it here?
No, I was just writing down, but we can move on. I just wanted to say I don't think we can assume really a single public IP, public interface for the node.
Okay. Let's move on then.
Okay. So this is about class IP service access from host. And the next subtask is to support node port service access. So as you know, there's no IP tables on Windows. So we can't do like the Linux that we have some nets on the host and do most of the logic there. So we can however we can have some other third-party network drivers, but these are extra efforts and we don't think it's worth it. So we are going to have all these nets, DNet, SNets into the OVS, and we hope this will by removing the Q-proxy, we are going to have a better efficient workflow, and yes. So if you want to remove the Q-proxy and support the node port service, there are 3 cases we need to consider. It's about the source. If the traffic source is from the external host, or it's from a local host, or it's from the local pod. And to support this, we need some extra flow tables. First, the uplink table, we already have it. And we need 2 filter tables. The first is to filter the node pod IPs, and the second one is going to filter the ports. So after these 2 tables, we only have those traffic related to the node port service. And after that, there's 2 NAT tables. One is the DNAT tables, and it is going to set the destination IP to a virtual IP. And the SNAT table, it will do the SNAT, change the source IP to the GW IP. But please pay attention that it will happen only when the external traffic policy is cluster. So let's take this graph to explain the pipeline. So we are going to first talk about the traffic from external host. So on Windows, you can see that from uplink, there's an external IP as a source and the node IP as a destination comes in here. And it goes through the filter tables, and then only those traffic related to the node port service will be left. And it goes to the DNAT tables. So then the source isn't changed and the destination is changed to a virtual IP. Also, the number 1 is set to the register 8 to show that it is a request. After that, we are going to go through the SNAT tables, and it changes the source, change it to GWIP. And now we have the packet from GWIP and goes to virtual IP. And we reuse the service LB tables. It do the endpoint elections. Then its destination is changed to the endpoint IPs. And now through the L2 forwarding out tables, the traffic go to the endpoint. And this is all for the request. And then how about the reply? It is the symmetry of the request process. The packet comes from the endpoint IP and it goes to the GWIP. It went through the service LB tables and the source is changed back to the virtual IP. Then at the L2 forwarding out tables, it will match the packet whose source is the virtual IP, and it will set 2 to its register 8. Just like before we set 1 to the register 8, the 2 means that it is a reply. So then it is very similar to the flow before, and it's at the SNAT table and it does on SNAT, and its destination is changed back to the external IP, and then the DNAT tables and the source is changed back to the node IPs. So it's so far you can see that the source and dest and the dest and the source. So this is changed back and going to where it comes from. Please pay attention that you can see that it is from the uplink, and its out is the Antrea G-type0. It's kind of different, but actually after it the traffic goes out Antrea G-0, it go back to your host. Since it's external traffic and only host knows where the route is, so it needs to go back to the host, and it goes back to the BRInt, and then it goes to uplink. So you can see the process is very similar to the current design by kube-proxy. So at this time, the traffic goes back to the external host or pod maybe, and this is part for the external cases. And then I'm going to talk about the traffic from the local host. Actually, this is much simpler than the case before, because we are going to reuse the service LB to the endpoint section, and the job, what we need to do is have a user space proxy here. With this user space proxy, this user space proxy is different from the kube-proxy before. We have kube-proxy here. The user space proxy only does simple job, like it takes in the packet from the local process, and it have a start a new traffic with the source as a GWIP and the dest as a virtual IP. And we need a new route here in the route table to let the traffic goes to the Antrea GW0. And once the traffic gets into the Antrea GW0, in OVS we reuse the service LB do the endpoint election. And this part it has already been done. And the traffic goes to some port, the traffic goes back, and it go back to the Antrea GW0, and we route it go back to the user space proxy. And here, it will send the result back to the local process. So the support for the local host is very simple. It's just on the host, need some route, need some user space proxy, and that's enough. Then the last one is about the local process.
Sorry, I'm not sure I got it. So for local process to access load port, so what will be the source IP? The source IP node IP, right?
Yes. Node IP, yes.
So actually you guys mean we need a user space proxy.
Yes.
I see.
It is going to translate the source and test like doing net jobs.
Okay.
I guess it's irrectable because on Windows there is no mechanism to steal the packets whose destination is the local host to OS, right?
Probably we should look at VFP thing, I guess.
You mean Windows?
Filter
Oh, okay. Yeah. Maybe.
Yeah.
Go ahead, Tree.
Yeah, I have looked at the VFP, but there's no framework like net filters in VFP. So if we want to do the things like net filter and type tables, we need to develop our own driver, network driver.
And we don't think it is worth the effort.
Yeah.
Okay. But on the other hand, the local process to access node port is not common, right? Do you guys know any upstream test to cover that or any use case for that?
I'm not sure. I can check the Kubernetes test, but I don't remember we have this kind of test.
I'm just thinking, should we just drop it? I mean, if it doesn't make much sense to support.
Yeah,
This kind of support from local node?
Yes.
Mm-hmm.
The user space policy, do you have any other requirements for that, or it's only for local host to access the port?
I think you just mentioned that there are cases that user may access the node port from another interface, right? And not from the uplink.
Sure, but I think even from sorry, you're talking about another case, right? Or you're still talking about some local? Yes. Okay.
Yes, if the connection is from another interface instead of BRInt. So I think the user proxy can handle this kind of traffic.
Okay. For this user space proxy only for load port, right? At least only for load port accessed by a local process or by another interface, right?
Actually, not only for node port. Justin will talk about it later.
Okay. Okay, Paul, let's.
Yes.
I'll let you guys continue then. Maybe we can see other case.
Actually, the local port case is even more simpler because it is going to reuse the logic here. The traffic from a local port, it goes out to the host through the Antrea GW0 with tables in OVS. And after that, since the traffic is on host, then the rest is the same as the local node situation with the user space proxy, and the route goes back. Maybe it's not so efficient, but this is going to work, and maybe we can investigate some better solutions later. But this time we are going to have the traffic goes to the host and do the rest the same as the local node's case. Yes, this is all for the node port service port and all for my presentation today.
Okay, so still user space port is only for node port, right? Can be a local process or local port or
yes, they all use it, and no other use.
Okay. I'm just talking about my thinking. I don't like user space proxy. I mean, we are saying we want to simplify the forwarding, but
yes, but maybe some traffic may happen for some reasons, and be prepared for them.
So probably I need to think more, but so far I'm thinking probably no need to support a local process to access node port. And for local port, you can handle it in OpenVSwitch if you want. And go ahead.
For load balancer case, like some in-cluster load balancer, do you think they will access the node port from the host itself, like MetaIP?
It's no, I don't think MetaIP do it. They typically just use. I think they typically just use. MetaIP that itself doesn't do any forwarding. It just use Kubi proxy.
It just use, so which destination it use when it access?
It's external IP. Sorry, what I mean by that?
I mean when it access, when you access
the destination IP is the external IP.
And it is translated to the endpoint directly, not via the node port. You mean?
I think it's by Kubi proxy. Kubi proxy probably translate external IP to endpoint IP.
Okay, I see.
And actually, I'm thinking on Windows, probably we made lots of assumptions that traffic should go to the uplink. I'm not sure we can keep the same assumption for now. I know it's not ideal. I mean, you guys are completely right. They can be multiple interface. Sometimes the default interface can be another interface. But I'm thinking if we at least our current implementation actually assume lots of traffic should go uplink. For example, SNet. Right. So I'm just thinking, should we just keep a simple assumption for now until we have a better solution?
We can support from the external cases first, and maybe decide later about the design of the rest.
Okay.
Okay. Is there any other questions?
Janjan, do you think we should check with GKE folks that the assumption is correct for their use case at least?
Sure, we can ask them. But I think so, right? GKE, do you know they support multiple NIC? I guess not.
Maybe Reno's, since he's been working with them. I don't
know. Actually, I'm not sure about that. I'm just thinking that it should be common to have multiple interfaces in one node.
You can be right, but I think it's not common for managed service. For example, if we look at all the distros I know, like TKG or PKS, or AKS, GKE, EKS thing, I don't think they support multiple links.
Mm-hmm. And especially for Antrea, because we will take control the uplink. So I think it's better to have additional interface for management, because if Antrea OS is crash, the connection may be broken.
Really, I think you guys have a way to restore the traffic, right? Yeah.
Mm-hmm. But it still have high risk.
Okay.
But as long as the default interface is the uplinks, and it's still okay. I mean, for Janjan's assumption, at least.
Yes. But if what if we install some incorrect flow, or user or anything change the flow? Yeah.
I don't think that's something we should
Okay.
handle. I mean.
Okay. Yeah, we can pin the GKE team, Yongkun, from the Slack.
Yep.
Mm.
All right. Is there any other question on this topic? Okay. All right. So I believe that we can. I mean, my only curiosity was about whether we have to enforce. I mean, I think we want to enforce the network policies also on traffic coming from the node port, right? And I was wondering, in that case, if one wanted to configure such a network policy, would it be evaluated before or after we do SNAT for the source IP? I just want to figure out if, normally one will configure a network policy by allowing only, for instance, a given set of ingress siders, and I wonder if in that case the network policy will work, or whether instead the network policy for node port should only be specified on the node IP itself. I don't know if my question was clear. Probably I didn't expose it very well.
Sorry, can you repeat? I didn't get the last sentence.
With the node port design that has been just proposed by Jecheng, I want to understand whether we can, for traffic coming from, let's say, from the outside world, if we can enforce Antrea network policies on traffic that goes through the node port, or whether we need to do some special treatment for Antrea network for filtering traffic that goes through the node port, because I think that we are snatting the source IP. So I don't know if when Antrea network policies are evaluated, we see the actual client IP or we see this snatted IP with the snatted to the node IP.
Yeah, Sato, I think it's a good question. That's also what we are considering now, because currently we just can confirm the traffic can be go through the right path. But for the policy, actually we're not sure if some policy rules may be broken. Currently we add currently we add the tables before the existing policy tables and after the tables. So in theory, the flow will go through the existing policy tables also as well, but we still need to investigate if there's an issue for the policy.
I think it's difficult to enforce on the external client IP, as the endpoint, the selected endpoint might be on another node, right? And we don't enforce network policies on this ingress node, right? We will only enforce ingress network policy on the nodes that the ports are running. So there's no chance to enforce policy on the original source IP.
We could add the original IP as a Geneve metadata, right? That would be a cool feature.
Yeah, that could work.
Okay, so thanks for addressing my question. So now we have another topic to discuss, but unfortunately we only have a little bit more than 3 minutes left in the meeting, which I believe might be better to defer the discussion of the Antrea reject policy to the next community meeting. I don't think that 3 minutes will be enough for Grayson, and also it's already 11 p.m. for people dialing in from the US West Coast. So Grayson, are you okay with presenting this in the next community meeting?
Yeah, I'm fine.
Okay, so sorry about that. the conversation on kubproxy removal took a little bit longer than expected. Is there any final question for Hong Liang and Jia Cheng and Ray about the kubproxy removal? Waiting 10 seconds. And therefore, it appears that it is all for today. And thanks everyone for attending. I'm going to stop the recording now.